According to meteorologists, it's theorized that there's enough energy in a thunderstorm to power an entire mid-sized city's electrical grid for a whole year. So the question then becomes, and many people have pondered this, how do you harness all that energy that's in a thunderstorm? Well, I have a clue parked behind me. So this here is a Toyota Mirai. It's a long story of how I got to this point, but this here has been my main mode of transportation since September, and the way that it runs is kind of significant when you're talking about coexisting natural water and electricity in the atmosphere. Water and electricity just happen to be the two key raw materials in the production of, you guessed it, hydrogen to fuel cars like this. So how do you take that combination of water and electricity that you find high up in the atmosphere in thunderstorms and convert it into hydrogen that we can use? Well, here's a diagram. And you notice a few things on it. First of all, this scale on the right. Notice how tall this thing would have to be in order to work. And then you have, in this case, a pair of conductive meshes, one at the 5,000 foot level to collect the negative charges. And then you have these positive charges collecting at the 40,000 foot level. Again, these are key components here. So imagine an invisible thunderstorm lining up with this artificial circuit. Well, what happens? Well, you have the array of cisterns on the ground and the array of electrolyzers. If you do this right, you basically can redirect the electricity that would otherwise get discharged as lightning if you didn't, through enough cisterns, enough electrolyzers on the ground to produce hydrogen easily in the order of several thousand metric tons per storm. I mean, inconceivably large amounts. At that point, it's only a matter of separating out the hydrogen itself into a bunch of pipelines and transporting it around the country. So what are the drawbacks? Well, for starters, you'd have to supply all the construction workers with oxygen tanks, pressure suits, and parachutes, because they would be building into atmosphere where hypoxia could be a potential issue that they would have to have protection against. It also would have to get clearance from the FAA, because this thing would be so massive, so tall, that it would actually stick up into the cruising altitude of most modern commercial aircraft. And of course, that means that it would have to have some kind of built-in transponder or some other mechanism to let pilots know that, hey, there is a fixed obstruction here that is sticking up into your airspace. Please make sure to avoid it. There also is, of course, an economic cost, major one, to building to these extreme heights, like 20 times the Burj Khalifa. But of course, the end result would basically pay for itself. So that's no big deal, because the amount of fuel coming out of this, you'd be able to easily make enough money from that to recoup it. So why is this a better solution to the fuel shortages than, say, fracking? Well, the main reason why is no matter how many new ways you find to abstract oil, you're still eventually going to run out. It's not a permanent solution. Every time you find a new source of oil in the ground, you find a new way to extract it, whatever, it's just delaying the inevitable. You're still going to run, whether you run out of oil in 10 years or 100 years, you're still going to run out eventually. Well, with this means of extracting hydrogen, because it's essentially taking water and electricity in the air and converting it that way, that's always going to be coming down. It's always going to be there. So it's the case of temporary energy independence versus permanent energy independence. And I, for one, am all about the latter. And of course, hydrogen can power a lot more things than batteries can. Obviously, this Mirai that I'm now sitting in is one such example, but there's also some hydrogen aircraft, because when hydrogen is used in a turbine, it can actually provide a lot of thrust, just the way jet fuel can. So it can be used to fly in addition to drive. You also can use it in some, if you have the right kind of hydraulics, the right kind of piston and whatnot, you also can make construction equipment and big heavy machinery that runs on hydrogen as well. So these are all applications that hydrogen can fill much more easily than a battery can. So yeah, this probably has to be the best thing anyone has thought of regarding harnessing the energy that you find in thunderstorms and in the atmosphere in general. And the more hydrogen vendors you share this video with, the more they might go, maybe I should think about that. So please share this with them as much as possible. Thank you.